In this video, I'm talking about division of complex number. The whole goal of this video is to present a way to solve this expression, and if we can solve this expression, we can solve all other general form of division of complex number. First, let's review what we have learned in the last video, which is important in today's video. We learned about complex conjugate. It is just complex conjugate has the same real part but different, but the opposite imaginary part with opposite signs. Now let's try if we multiply the two complex conjugates together. If we represent a complex number a plus bi, and its complex conjugate must be a minus bi, and the result is a squared minus bi squared. Now bi squared is equals to b squared times I squared, and from the first video I squared is minus 1 and the negative side gets killed, so we have a squared plus b squared. And we know that a and b are real parameter, so a squared is positive, b squared is also positive. So the product of two complex conjugates are bigger than 0 and real. That's really important because an analogy is that when we try to divide it, a rational number by a rational number, for example, 2 divided by root 3, and we try to turn the denominator into a rational number. What we do is we multiply by root 3, so we know that it could turn it into a rational number. So this results in 2 times root 3 over 3. Now what we do is similar to the complex number here. We just times the denominator by its complex conjugate, so the denominator becomes a real number, and the numerator could either be a complex number or a real number or even an imaginary number. So let's do it together. 1 plus 4i times is the complex conjugate 3 plus 2i, and at the denominator we can just expand this 3 squared plus 2 squared. Remember this expression results in a squared plus b squared. Remember in the second video about multiplication of complex number, where this is a 1 here instead of an I. So we do like this, 3 plus 2i. So in this way we won't miss any terms, plus 4i times 3, 12i, plus 4i times 2i, which is negative 8. What happens to the denominator is that 3 squared is 9 and 2 squared is 4. So this is 13 at the denominator. Now we need to add the real part together, which is negative 5, the imaginary part together, which is 14i. Okay, so this is very straightforward. Now, if we relate the division of complex number into complex conjugate, we get a rule. We divided the one complex number by another, and complex conjugate them. The result is the same as we first complex conjugate the two complex number and then divided them. Now you could, similar to the multiplication rule where the two complex numbers, the product of two complex numbers, and then you complex conjugate it equals to z star x star. You could prove it using the Cartesian form of complex number, but we'll come back to it after we have learned about the exponential form of complex number, which is very useful in calculation involving multiplication and division.